enable, oh, we're recording now. A good way to enable quizzing and recall practice, which some of you have asked for, more quizzes, more recall practice. Instead of us making more quizzes for you, which is teacher directed, to be student directed and have your own locus of control. Here's an easy way. So you get Eagle or your AAO textbook, and you may be studying a particular chapter or just random, and you open up your textbook, and you look at the figure, the diagram there, and there'll be, you know, like A, B, C, D, but you cover over the legend, and then you look at the picture of the histology, and then you go through and you write out, you know, what is the normal tissue? What is the abnormal tissue? What is the diagnosis? And it forces you to recall. And then, of course, the answer there, you uncover the legend and you've got the answer. And those are very targeted photographs that show exactly the features that are characteristic or pathognomonic of that particular diagnostic entity. It's an easy way to practice recall.
And so another suggestion was that there is a summary sheet at the end of the day. I kind of think of the PowerPoints as summary sheets, but I reckon that's another good student project where you can create, you know, an online document on the Google Classroom, and you can, I'm sure you're writing notes as you go along, but post your notes there and other people can add to them as a summary sheet. It would be a great collaborative document. I'm going to share the screen to show what I did in the Google Classroom last night.
Ooh, a horrible looking eye.
Here we go. So I worked with the key resources last night. There was a comment about it would be great to have a slide box. So I want to introduce you to the AAO Pathology Atlas, which I think is the best pathology slide box around. So if you haven't discovered this yet, you should register. And lots of the slides from today are from this. So if you're sitting here listening to the chat, it will be a good time to register for the AAO course by clicking on that button in the Google Classroom. And here we go. Right, so we've got lots and lots of drop downs here. So we've been doing, for example, the retina, here we go. And it's got lots and lots of slides here showing the retina. And then it's got de-identified images, which can either come, you can look at the slide initially and try and do it. And then it's got an annotated version where it shows you all the things you should have seen. So that's a really good slide box. Okay, so you can click here for annotations, here for the original image, and test yourself with lots and lots of slides. And the other thing that is really good, though slower loading, is the Leeds eye pathology slides. So if you follow the link here, it takes you right to little files of slides. Okay, there we go. So for example, back to the front here, you wanted more exam practice. So on CuraCloud, I made a new lesson. Here's CuraCloud. We'll just go to the home here. So here where it says eye pathology practice exam questions, I have put in 4 cases like you would get in your exam. So I've reminded you that this is what you've got to write. This is your answer here. And these are a set of slides that I've taken. This is a virtual slide. I've taken pictures like you'll get in your exam. You have to write your exam answer, and then you're only allowed to go forward. Hang on. You're only allowed to go forward if you've actually written something. That's what that commit box is for. And on the next page is a model answer. So I'm trying to force you to write things. I'll just pop out and go to the admin lesson so that I can show you what the rest of it looks like. If I'm pretending to be a student, I have to actually write an answer in that box. So here we go. We've got the original page, and then we've got the commit page. Oh, hang on. Then I'll edit it. You commit it, and then you get your answer here come up, and then you get my answer here underneath it, so you can mark it. Okay, so I've done that in Kura Cloud for you. And in addition, here, there is an exam practice PowerPoint. Okay, so you go through the exam practice PowerPoint, which is key slides that you need to be able to recognize. You can download it as a PowerPoint. So here, you've got to look at the slides and make a diagnosis. And then after that, you know, I'm very kind, I'm pointing to some key features here. You get the answer, and then you know, get the slides labeled. But it's really important that you actually write down what you think it is before you look at the answer. Otherwise, you aren't testing yourself properly.
You're just testing your ability to read.
Yeah. So you have to actually hide the answer. There's lots of cases. There's 382 slides in there. So like mega exam practice. All right. And the other thing I found was this lovely knowledge quiz here, which is the OKP and board review quiz, which again is on the AAO site. And it is a series of PowerPoints again, where they ask questions, and then you've got to actually write down your knowledge, and then you can check whether you've recalled your knowledge. So this is all about knowledge recall. Okay, I'm going to stop sharing. Right, so Nish asked, is that 5-question stem the same questions they will ask in the exam for the 2 slides? Yes, that is the one that they have used before. I have to tell you that the exam's not written yet. This time we are going to write it in a few days out. Well, the examiners, not me and Amanda, the examiners.
You know, the chief examiners get to choose the questions.
Yeah, so anything we say is no hints about what's in the exam, because
we're not the chief examiners, so we don't decide.
Okay. All right. So should we start? Are there any further questions? I believe on the schedule for today, we are going to start with me giving a brief run through of key histologic findings in glaucoma. And this is going to be a fast run through because you should have already read this in your book, but this is a quick reminder. Okay, off we go. And I'm going to share screen, start the PowerPoint, go to the top of the PowerPoint, and go full screen. All right, here we go. So when you're thinking about glaucoma, you should think of the posterior histology and the anterior histology. The posterior histology is going to be the same for all glaucomas. Okay, so you've got to think of things that are happening in the optic nerve, and particular, remember cavernous optic atrophy as well as cupping, and also remember glaucomatous retinal atrophy, which has several parts to it, as well as the loss of ganglion cells, there's loss of the nerve fiber layer, and there's often gliosis in the nerve fiber layer. Right, so here we've got cup. Note that the lamina here is bowed, okay, and the optic nerve is looking slim. This is a comparison of normal retina and glaucomatous retina. So we talk about absence of ganglion cells, but really things are generally slimmer. There's loss of nerve fiber layer, there's the photoreceptor ganglion cells are okay, but the nerve fiber layers are all thinner. Right, I'm going to look very carefully through these ones, which are just taken from textbooks. You're going to look at the back after you've looked for cupping and bowing. You're going to look for increased widening of the subarachnoid space. So normally the nerve swells out after it goes to the lamina cribrosa, but in glaucoma, there's increased space. Yep, thinning of the nerve fiber layer. Again, this doesn't swell out. There's widening of the space. Bowing of the lamina cribrosa, widening of the space. Gliosis. Okay, and I can't see the top one here. Yep, again, cupping, gliosis. And this is cavernous optic atrophy. It just starts looking like Swiss cheese here in the behind the lamina. This is a normal peripheral retina. Yep, ganglion cells. This is a normal central retinal, ganglion cells. So if we get a glaucomatous retina that looks like this, what we're looking here is astrocytes and there's no ganglion cells. And you can have ganglion cells still left in the macula, but they can be like half the normal amount. So you kind of have to calculate your degree of ganglion cell loss depending where in the IUR, because if you had something like this and it was in fact in the macula, that would be too few. Let's look at the front of the eye. Remember, we've got lots of things happening in the front of the eye. I'm sure you're pretty up with the normal anatomy, but I want you to look in particular the relationship to the iris root and the trabecular meshwork, because one of the commonest things we're going to get is we're going to get anterior synechii. So it should be well behind where the trabecular meshwork ends. Right, lens-induced glaucomas. Phacolytic and phacoantigenic. So in your learning, you should be able to describe the difference between these and the difference in the histology. Okay, what have we got here? What we've got here is an iris. Here's the iris. Yeah, we've got this is the lens capsule here. It's all baggy and empty, so something's gone on here. Here we've got the iris root, and we can't quite see the trabecular meshwork, but it's probably here. But there's pink stuff here in the anterior chamber where there shouldn't be. And if we look closely, particularly on the anterior surface, like around here of the iris, we can see macrophages, some of them with pigment in. So in the chat, I want you to tell me is this phacolytic or phacoanaphylactic? It's phacolytic, that's right. So we've got the lens material being taken up by macrophages. I've just seen the comment from Nish asking, could we point out the astrocytes on the slide? I'll go back and do that at the end. Okay, so what's this one going to be?
Same choice of two.
Yeah, or yeah, phacoanaphylactic. That's right. Because here, oops, I've got to just go back up. Here we've got the actual lens breaking down, and this is a granulomatous reaction to it. We've got a giant cell here. Sure, there's a whole bunch of monocytic cells here, but here we've got a granulomatous reaction, and it's the granulomatous reaction which is the easy way to tell the difference between the two, plus there's a ton more reaction. One of the questions that might come up is the immune reaction. You know, those basic science questions, it's really worth understanding the difference in immune reaction between phacolytic and phacoanaphylactic. Okay, so here we go. Here's the trabecular meshwork. The angle should be back here, but it's not. Right, so this is, of course, anterior synechii, which is present in neovascularization. So once we've got a neovascular eye here, we've got to then ask, why is the neovascularization occurring? So then I look at the front of the iris. It's ironing board iris. It's really flat. I bet there's going to be little new vessels along here. And then I look at the back of the iris epithelium here. In diabetes, this is often vacuolated, and this can be the first clue. As you know, there's a wide range of things that can cause neovascularization. So when you're looking at the back of the eye, as well as looking for the secondary glaucomatous changes, look for all the things like the diabetic changes or evidence of previous vascular occlusion. Okay, there we go. This is what should not be there. All right, so this is the lens capsule, anterior lens, and we've got this little tree-like fluffy stuff growing off the front of it. What's this? PXF, that's right, PXF. So in PXF, you look to find the fluffy stuff, you look on the anterior lens. That's the best place to find it. If you start looking around the trabecular meshwork, it can all get a bit hidden in the trabecular meshwork. In pseudoexfoliation, as well as the fluffy stuff on the front of the lens, you also have increased pigment, and that can travel to the trabecular meshwork as well. So there's a whole variety of stuff that increases pigment in the trabecular meshwork. In POAG, you get increased pigment in there as well. In melanoma-lytic, you'll get it there as well. And in the, sorry, I've forgotten the name, the one where the back of the iris rubs on the lens, what's that called? You get it in there as well. So there's lots of pigment that you get in the trabecular meshwork. It's not specific. To look for pseudoexfoliation, you look here. Okay. Traumatic glaucoma, angle recession, epithelial downgrowth, and blood. So here we go. This is an eye. It's been traumatized. We've got a whole lot of blood here. This is the trabecular meshwork in the canal of Schlemm, and the angle should be here. And this is an acute recession, though you can get chronic recession as well. Okay, so here's the trabecular meshwork, right? This is pointing to where the angle of the eye usually begins. And there's, sorry, no, this is the big, pointing to the end of the scleral spur, okay? And the angle has recessed backwards along the scleral spur. Right, a few more glaucomas. Right, this is aniridia. This iris is small and runty, and there is no good trabecular meshwork or canal of Schlemm. If you're wondering what Hab striae look like down the microscope, this is what they look like. They look like little curls of Descemet's membrane. So this is a PAS stain because it's staining Descemet's bright pink. And we often use that to look at abnormalities in Descemet's. Okay, right, here we go. So here is a bunch of pigmented macrophages in the trabecular meshwork. So we've been through a variety of things that can cause melanin to occur in the trabecular meshwork, but sometimes the pigment is hemosiderin. So we've talked about hemosiderin before. It's about blood breaking down and going yellow, just like in bruises. What stain are we going to use to prove that these are in fact macrophages with hemosiderin in it? Okay, so IHC is not useful, Nish, because there's still macrophages, okay? So the cells are still macrophages, and yes, so Prussian blue. Prussian blue is the answer, the iron stain, Prussian blue. Alcium blue, Philomena, is used for mucopolysaccharides. Yep, so they use an iron stain, and the usual one is Prussian blue. Okay, right. So pigmentary glaucoma, which is the one I was thinking of before, you get lots and lots of melanosomes here in the trabecular meshwork. Here they have done a tall blue, but what it's showing up is the trabecular meshwork, the endothelial cells, yeah. Whereas iron will be blue in the cells. Okay. Pigmentary glaucoma. Melanoma-lytic glaucoma can be so dramatic, yeah, just absolutely full of pigment, and these are macrophages, yeah, with melanin in it. Of course, you can get direct invasion of melanoma into the trabecular meshwork as well. So you've got to take the context into the eye into account. This would be, for example, post-radiation, or if you had a melanocytoma that was undergoing some kind of involution or infarction. Right, secondary angle closure, some other things. All right, so here we've got abnormal epithelial downgrowth here on the front of the iris, which has closed up the angle. So this is epithelial cells from the surface of the cornea, which is growing across the front of the iris. Here we've got ICE, okay? So iridocorneal epithelial syndrome, this is here Descemet's membrane, and now it's growing over the front of the iris here, okay? It's also closed off the angle. So look for stuff on the front of the iris. Here's ICE again. This time it's got a PAS stain on it, which shows up Descemet's membrane, and you can see the bright pink Descemet's membrane coming around the corner and over the front of the eye. Right, in neovascular glaucoma, possibly the most common kind of glaucoma I see, you have these anterior synechii, the ironing board iris, the ectropion, and the ton of new vessels on the front of the iris. So what do new vessels look like? So that normal iris vessels have got little cuffs around them. There's one here. And the new vessels are tiny, tiny little things on the front of the eye. On the front of the iris, rather. Right, primary open angle glaucoma. We see some, this is again the PAS stain, we see some pigment in the endothelial cells of the trabecular meshwork, and also sometimes we can see that the fibers here are thickened, but otherwise it looks relatively normal up the front. Trabeculitis, right? So very occasionally you get lymphocytic infiltrates in the iris, you get uveitis, and then you get trabeculitis. Yeah, here. And sometimes you can get cancer growing in tumor cells, growing in the angle. So that's cellular infiltration. And that was my very fast review of what you should have learned from the textbook. Okay, are we good? Are we ready to go now for the first slide? Yes, we are. Yes. We are all keen here. All right, has Reza been able to join us for today?
Just looking down the list.
I can't see Reza.
I don't see Reza, no.
All right, so it's just the two of us.
Okay, we might need larger groups, otherwise we won't get around you all. So.
Okay, so I'm going to do breakout groups. There's 23 people plus Amanda and I online. So if we do 8 groups of 3 or 4 groups of 6, we'll do 6 groups, Amanda, with 4 people in.
Okay.
And we'll be able to get around them all that way. And have you all got your schedule up?
So you can click on the slide, ready to go. Whoever's
click on the slide, get that slide open.
Ready to be turned to be a driver.
Okay, off we go. I'll put you in 6 breakout rooms. And go. Right, and you're monitoring the chat there, Amanda.
Yeah, I'll bring that up and I'll interject, and then if there is a curly question, I'll ask the person to unmute and you can elaborate if necessary. So if there are particular features that you would like demonstrated, type them into the chat and then we can coordinate that.
Okay, I will share the screen.
We can go in the normal way from anterior to posterior, low power to high power.
Yeah. Okay, so at low power, we're able to see that there's clearly, there's a cup here and that the optic nerve doesn't swell out. We can see that there is separation of the retina from the back. Here we can see that there appears, even here we can see that there's an odd looking iris, right? It's very flat and it appears to have anterior synechii. Low power, there's something wrong with the lens as well. We've got a bit of pigment here which indicate that there's been a posterior synechii as well. So already we know this is a non-tumor eye that is glaucomatous. And well, come on, we're going to start. We are going to start at the front. Here we go.
So why is it glaucomatous and why is the lens looking funny?
Yeah, so yeah, this is what we've got to work out. So starting at the front of the eye, the cornea looks pretty good. So the epithelium's fallen off the front a bit, but I'm not too worried about that because it does fall off the front a bit. I'd have a look here. There's a purple line and I'd start wondering about whether there was band keratopathy here at the front. Let's go right up close. I can't get close enough here, but if you do see a purple line here, make sure there's not band keratopathy. I scroll through to the back and there's a ton of normal endothelial cells here. So the cornea has lost its epithelium, but it might well be okay. Oh no, I think it might just be remnant epithelium. And then we come to the angle, which is closed. Yeah, so closed angle. So trabecular meshwork is around here, it goes from here to here, and it is stuck down. And we can't quite see the canal of Schlemm. There's often blood in the canal of Schlemm. Back here, there's the meshwork through here. Can't see the canal very well.
Should be around there somewhere.
Yeah, it should be around here, but it's not shown. So blood happens with eye extraction, and if it's fresh, it doesn't mean a lot. So let's have a look at the front of the eye here. So
while you're on the cornea, would it be necessary to comment on the thickness of the cornea?
Yeah, so it would be probably. I was going too fast, and the cornea is of normal thickness. It's normal thickness, yeah. And there's no neovascularization or inflammation, and there's no edema. There's a little bit of episcleral vascular proliferation here. So maybe this person, did they have a pterygium or a pinguiculi? Maybe not. It just looks like a bit of injection around there. Right, this iris. I'm very interested in this iris here. So this is a new vessel here. This is designated new vessel, new vessel, new vessel, new vessel, new vessel, new vessel, new vessel. Deeper here. There's a kind of cuff around that one, and here, old vessel. Right, new vessel, new vessel. This iris leaf is much better than the other iris leaf, new vessel. So one of the helpful things is to look at both the iris leaves. We've also got some macrophages with pigment around the top, around here, which is probably just due to the chronic state of glaucoma in the eye.
So Diane,
yeah.
Can you elaborate more on how do you tell the difference between new vessels and pre-existing iris stromal vessels? I see there's some really good ones just right under your cursor there.
Yeah?
Yeah, pre-existing iris stroma vessels that are not neovascular, but they're fairly anterior.
They have cuffs. See how they're cuffed? They've got the epithelium, the endothelium rather, and then this layer of fibrous tissue around them that makes them cuffed. And that's a normal iris vessel. Cuffing.
It's not very dark on this one, but we'll look at some.
Whereas the new ones, which are down here, are right on the surface, and they're just like delicate. These are all new. They don't have cuffs.
Capillaries, so no
capillaries. Like this is a cuffed one here, so this was an original one, but this one isn't.
Yeah, they don't have a wall, they only have got endothelium. Can you tell if the pigment on the anterior iris is hemosiderin?
Because of my many years of experience, yes, because it has a subtly different color to the hemosiderin. It is more golden. And there's nothing here that might indicate there's been bleeding in the eye. So I probably wouldn't stain those up. I'd probably note the color was the same as melanin rather than more golden. And on my real microscope, I would also notice it was a bit more refractile. And then there's this. Posterior synechiae. It's been a posterior synechiae in the past. And the ectropion is best seen on the other eye. Moving up to the lens.
Oh, could you comment on the posterior pigment epithelium?
Yeah, it is a bit holy, isn't it? There's some mild laciness that I think is consistent with diabetes, but it's not the most impressive.
It's suggestive, isn't it?
It's suggestive, yeah.
Because some of my group suggested that. I thought that was a good suggestion.
Right. So this lens is abnormal. We know it's got an abnormal shape. We know that there's posterior synechiae on both sides. And if we look at it here, it's breaking down, isn't it? Yeah, this lens is cataractous. It's got the globule formation here. Yeah.
How do you know they're not red blood cells?
So how would red blood cells get into the lens? And also they're too big. They're big and blobby.
Yep.
All right. So is there any anterior fibrosis? Not really. It's just like globule formation. So this is the cleft and globule formation that you see in cataract formation. There's another whole lot of breakdown here.
And can you comment on the ciliary body, particularly the inferior one in this slide?
Sure. So the inferior ciliary body here is hyalinized. And it's got a couple of incidental cysts. So here are the incidental ciliary body cysts. And this is the hyalinization. It's a normal age-related change. Amanda and I will have hyalinized ciliary bodies. You young people in your 20s won't. Right, moving around the back, as I move around, what I'm looking for is the presence or absence of burns. Okay, so retinal burns look like focal replication of the RPE, and I can't see any. And you can see that these retinal photoreceptors look pretty normal, as if they've been torn off, which they have been. And the choroid looks okay. So we quickly scoot around here to the back of the eye, where we notice that there is, where the macula should be, there is a lack of ganglion cells. Right, inner nuclear, so inner nuclear, outer nuclear, nothing. Ganglion cells absent with a capital A, completely gone, not even a hint.
I didn't see any at all.
Gone. Oh, and this is the these are the astrocytes niche. They're the things that are left behind. Right, so here we go. Oh, there's a little bit of couple of drusen here. That's interesting. Yeah, and then at the back, we've got a few more macrophages again. Yeah, we've got some blood. And then we've got, I think there's probably some neovascularization going on here. This bit, I think, is all neovascular membrane. So we've got the optic nerve, the lamina here is bowed. And then I think this is probably a bunch of little vessels. So why do I think this is a bunch of little vessels? Partly because I know that this is kind of glial tissue that shouldn't be here. And then that could be a vascular loop here. They're really like tricky to find. I think I saw some around here as well, where this is a slightly better example where we've got little new vessels here. They're small capillaries as opposed to the thick normal ones here. I started looking at these and thinking, are these occluded? But I think they could be collapsed as well, and it's hard for me to tell. And of course, people with diabetes could also have central retinal vein occlusion. So one of my teams commented that disc neovascularization is more common in diabetes than it is in vascular occlusion. So I didn't actually know that because I'm not a clinician, but that was a good point. So I think this is neovascular glaucoma. There's indications of diabetes. There's disc neovascularization as well as iris neovascularization. There's a cataract and there's no sign of treatment effect.
Couple of more questions. And if she says, isn't the hyalinization, I think he means of the ciliary body, also a change seen in diabetes besides aging?
I haven't. So diabetes is well known for hyalinizing things, particularly vessels. I don't know whether there's advanced hyalinization in diabetics. You could you ask the question maybe by saying, do they become presbyopic early? Ciliary muscle become hyalinized in diabetics early?
Don't know.
I don't know.
Well,
do you guys clinicians know?
I mean, almost all adults have hyalinized basement membranes in their ciliary bodies.
Yeah.
Also, how often is the retina still adhered when there has been laser? Is this a true retinal detachment here?
No, it's not a true retinal detachment. It's an artifactual retinal detachment. And quite often when there's been lasered, it survives the histologic processing and the choroid and the retina are stuck down, and then it lifts off in between the laser burns.
Okay. Oh, good. I think that's it.
Great.
Is the anterior Seneca eye indicated simply by the angle closure, or do you also look for fibers in the angle? Fibers. What sort of fibers, Jess?
I haven't heard of fibers in the angle. I just usually look for new vessels. There's one there.
Yeah, that's angle closure.
That's the anterior Seneca eye happening just there.
Yeah. Is the hyaloid still attached to the disc? I don't think we've got any hyaloid in here. You mean like vitreous? It's fallen out. So, and can you show the ciliary body hyalinization again?
All right, sure thing.
And Jen is just trying to put it together. Is the vacuolization of the iris pigment highly suggestive of diabetes being the underlying cause of the neovascular glaucoma?
So I think this is highly consistent with diabetes as a cause of neovascular glaucoma. Yeah.
Whereas iris cysts are not related to diabetes, as far as I know. It can happen to anyone.
Okay, I'm going to stop sharing.
Okay.
And I'm going to, that was pretty good, wasn't it?
That was good.
So we did a, like the AB thing yesterday where people went through it.
Okay. And I think we'll keep on doing some of that because we only did 6 slides yesterday, and there were interesting mixed reflections on that. And I think if we keep going forward a little bit, it'll give you an opportunity to think a bit more about how this might impact upon your learning.
Do you think I should go through the next slide and then people can look at it? We'll do an AB.
Or maybe we'll do like in each chunk, we'll do it the same way. So
okay.
So the next one will also be student first, and then the next block of 2 slides we'll do tutor first. What do you reckon, team? So
Yep. All right, here we go. We're going to put you in breakout groups again. I'll just pause the recording. All right, has everyone had their first cup of coffee now? Everyone's just coming back. Yeah. Going to do, good to do some, slight stretching and shoulder rolling exercises there. I could play some music and we do some chair dancing. Yeah, I know I am a bit mad. It's all right. I understand.
Very young at heart.
Alrighty. Okay. I'm going to open the slide up here and share it. Because everyone's back now. Hello, everybody. So I thought this slide was done really well. Low power. We have a different. This is
a different slide. It's the next one.
All right, here we go. Let's go to this one here. I'll click this one here.
Shall I throw a few questions at you?
Yeah, go for it.
Just from things that we discussed. I think people just described the cornea very well and the iris very well, and everybody came to the conclusion there was open angles, but there was some material inside the open angles. And there was debate in my groups whether it was pigmented or not.
Okay, so the clue to what's going on, I think, is at low power, because you can see actually at low power, this lens is bad. It's got a very sclerotic nucleus, and then it's got this odd shape where there's this pink fluffy stuff. So yeah, so there was.
Oh, you're not sharing.
Oh, sorry. Okay, share screen. All right, here we go. So yeah, so it was an odd shape, and the nucleus and the cortex were not symmetrical. So we knew that something at low power was going on. Here we are here. So yeah, what is all the stuff? And are they pigmented? So some of them might be very lightly pigmented, okay? So here, for example, I can see a couple of granules. Here, macrophages love to eat melanin, but most of the thing that we're seeing is pink fluffy material, the same as was in the lens. One group cleverly pointed out that they were also on the posterior surface of the, here's one, posterior surface of the cornea. So keratic precipitates were present. And yes, there are tiny, tiny dots of pigment in them, but that's what macrophages do. They love eating pigment.
So does that mean this is like a pigment glaucoma?
No, it's mostly it's the fluffy stuff. It's the same fluffy stuff as here. And I reckon the differential diagnosis when seeing the macrophages is either going to be phacolytic or exfoliative. Okay, there was massive loss of ganglion cells at the back here. So that's the other thing that people
we had a good debate about that. Again, because one of the layers was really squashed. So
yeah. So here's the fovea.
Oh, that's a good section, isn't it?
Yeah, it is. Yeah. And next to the fovea, there should be massive, massive numbers of ganglion cells, but in fact, there's just 1, 2, and 3.
But wait, what about, there's another layer. We were looking at this closely in one of our groups. So if we go from the other side, RPE, and then from outer to inner, on high power, just there.
Over here.
No. We back where you were.
Where I was.
Yeah, that's good. Okay, zoom in there. What's that dark? So there's there.
Oh, maybe I was wrong. Yeah. Oh, right. Okay.
It's just been squished like this.
I was wrong. I put you wrong, my groups. Right. Right. So I put you wrong. You're right.
3 layers.
And I'm wrong. This is the photoreceptors. This is the outer nuclear layer,
which has been
squashed. Like the inner nuclear and the ganglion cells.
Lots.
So there are in fact lots there.
Yeah.
Oh no, I got that wrong. Failed.
So my group was debating about that, and we discovered the answer to this by going to the more anterior part of the retina and comparing and contrasting our layers.
Right.
So
because I thought that this nerve was quite thin here, and there was.
I thought it was atrophic looking.
Yeah. So
yeah.
Right. All right. So you went round to the more peripheral parts.
Yes.
Where it was less squashed.
The reason for squashing, we don't know. The reason for squashing.
So here.
That's outer, yes.
Cells. But I think they are reduced,
They are in this part
the outer
here.
bit. And we know the outer bit goes first in glaucoma.
Yes.
Don't we?
Yeah.
All right. So we've got glaucoma where there's peripheral loss, and the central area is relatively preserved.
It's preserved. Yes.
Yeah. Okay.
And so, yeah, it's a sort of the outer nuclear layer here is about normal thickness pragna. It's that white space in between. They've been torn apart during the cutting process.
Yeah, you can just, outer, inner ganglion cells. Yeah.
And a few ganglion cells left. So. Okay.
On this, are there any more questions?
To reiterate the optic nerve findings, is that cystic degeneration in the optic nerve there?
Yeah, I had to think about that and wondered whether it was cystic degeneration or vessels. And I think it could well be a vessel.
I thought it was the vein. Yeah.
This is the artery here, and this is the vein.
central retinal vein, so not cystic degeneration, because it looks like
Artery in the
endothelial cells.
vein. Yeah.
Yeah. Can you comment if the retinal nerve fiber layer is thinned? Well, I guess we'd kind of expect it to be with those optic nerve changes, wouldn't we? Yeah.
Yeah. So it's hard to spot. I found it one of the hardest things to spot, thinning of the optic nerve layer.
Is the prelaminar tissue reduced? Thinking of the glaucoma. Well, it's cup shaped.
It's vaguely cup shaped, isn't it? There's a kind of shallow cup.
Depression. Yep. Okay. Yes, and so Jan, that's not retinoschisis, that's an artifact in the retina, the white space. Okay, good.
Let's move on. Right, here we go.
Time for a break, isn't it?
5-minute break. Time to get
5-minute break, cup of coffee.
Coffee, etc.
Move away from the screen, look into the distance.
Yeah, do that. So I'm going to stop sharing. We're all going to get up and we're going to come back in 5 minutes.
Yep. And then we've got 2 more.
And then we've got 2 more slides. Yeah.
And then should we do these the other way around? Diane, we'll do tutor first, followed by student breakout rooms.
Yep.
All right. Go and get a cup of coffee.